Welcome to everybody. In this lecture, we are going to study the linear differential equation with constant coefficient. That is a new chapter of BSc 1 syllabus unit 2. So BSc 1 unit 2. So linear differential equation with the constant coefficients. So this is a new chapter here. So what is a linear differential equation with constant coefficients? Before that we have to study here the first order and first degree differential equation. So what is the definition of this equation? So what is the definition? An equation of the form dny by dx raised to n plus p1 dn minus 1y by dx raised to n minus 1 plus p2 dn minus 2y by dx n minus 2 and so on. So what is the nth term? Pn y is equal to x. Okay, so this is a differential equation. So why it is called a linear differential equation? So of nth degree. So this is nth differential coefficient. So n, then n minus 1, so then n minus 2, n minus 3 and so on. So this equation is linear and the coefficients. So coefficient of this differential coefficient is p1, p2, pn are constant. So linear nth degree linear differential equation with constant coefficients where x is a function of x only are constant and p1 p2 dot pn are constants. Okay, so this is the linear differential equations. So linear means, so this is n the differential coefficient n power n order, then n minus 1, then n minus 2. That is a linear differential equation with constant coefficients. Okay, but x is a function of x and p1, p2, pn are constants. So for example, so that is dqy by dx cube minus something 3 d2y by dx square plus 2 dy by dx plus y is equal to 0. So this is the example of differential equations. So how to solve this differential equation? So to solve the linear differential equation, how to solve linear differential equation? Method, we learn here method of solution of that differential equation. Okay, to solve. So we consider this equation again. So that is the dny by dx raised to n plus p1 dn minus 1y by dx raised to n minus 1 plus p2 dn minus 2y by dx raised to n minus 2 and so on. So this is a linear differential equation. Okay, p and y is equal to 0. So that is equation number 1 here. So equation number 1. Using operator, we simplify this equation using operator. So that is a d is equal to d by dx, or d square is equal to d2 by dx square, so and so on. So the equation becomes here, this equation becomes, so that is very simple, dn. So we replace this differential equation by using the operator d raised to n plus p1 d raised to n minus 1 plus p2 d raised to n minus 2 and so on. Pn into y is equal to 0. So this is equation number 2 here. P and y 0. Okay. So the auxiliary equation is, auxiliary equation. What is the auxiliary equation of that? So that is dn plus p1 d raised to n minus 1 plus p2 d raised to n minus 2 plus and so on, pn is equal to 0 simply. So this is equal to 0. So this is auxiliary equation. So this is algebraic equation. N degree, we say here, this is algebraic equation. So this is n degree equation. So by fundamental theorem of algebra, if the equation having n degree, then it has n roots. So it has n roots. So we get n roots. Say m1, m2, mn. These are the n roots of this auxiliary equation. Okay. Now we suppose y is equal to e raised to m1x. m1x is a solution. Okay, just we suppose e raised to m1x is a solution. So suppose this is solution, so we put this in equation 3. So what will you get? So that is, before that, what is the d of e raised to m1x is equal to, so that is the d means capital D is an operator, so that is the d by dx means the derivative of e raised to m1x. So m1x. So that is, what is the derivative of this? E raised to m1x into derivative of m1x is m1. Into derivative of m1x is m1. Similarly, so what is the d2 by e raised to m1x? Again, d2 into e raised to m1x. So that is d2 by dx square. So second order derivative of e raised to m1x. So this is what? First derivative is this, m1 e raised to m1x. Again we take derivative. So that is the second order derivative. So e raised to m1x derivative, e raised to m1x into its derivative m1 into m1. So that is m1 square e raised to m1x. Okay. And so on. So directly we write here d raised to e raised to m1x is equal to m1 raised to n e raised to m1x. Okay. So putting this, so d of e raised to m1x is equal to m1 e raised to m2x. So d2 e raised to m1x is this, dn is this, in this equation. In this equation. So we get, so LHS is equal to LHS, left hand side of this equation. So what is the dn? D raised to n. D raised to n is m1 e raised to m1 raised to n plus p1. Similarly, d raised to n minus 1 is m1 raised to n minus 1 plus p2. P2 d raised to n minus 2, so that is m1 raised to n minus 2, and so on. Pn into e raised to m1x, e raised to m1x, e raised to m1x. So left hand side of this equation is this, and this is equal to 0. This is equal to 0. So why it is equal to 0? So forget it. Forget it. So y equal to 0? Because if we suppose m1, m1 is the root of that, then that root m1 satisfy this equation. Therefore, this equal to 0 here. Okay. So m1, what is the root here? So roots of these equations are, say, m1, and m1 is the root of this equation. Then the equation is satisfied by m1. So this is equal to 0. Therefore, the solution of this equation is y is equal to e raised to m1x. So we suppose here, so y is equal to e raised to m1x is the solution, and we solve it. Therefore, y is equal to e raised to m1x is the solution of this equation. But this equation has n roots, okay? Therefore, similarly, m2 is a root. m2 is a root of equation 2 here. Equation 3 or 2. Then what is the solution? Y is equal to e raised to m2x. If m3 is the root of this, then y is equal to e raised to m3x. Therefore, what is the complete solution of this differential equation? Therefore, the complete solution is when m1, m2, mn are the different roots, then the solution of this equation is y is equal to what? C1 e raised to m1x plus C2 e raised to m2x plus m2x, and so on, Cn e raised to mnx. So this is the complete solution. So C1, C2, Cn are n arbitrary constant. Why taking those constants? Because this equation is nth order differential equation. So order of that equation is n. So its solution having n constants. So we get here n constants. So this is the complete solution of the differential equation. So we take example. Simple example. So how to solve that example? First, find the roots of that equation and write the solution of that equation directly by using this formula here. Okay? So solve. Solve. Example. Solve. dqy by dx cube minus 6 d2y by dx square plus 11 dy by dx 11 dy by dx minus 6y is equal to 0. Solve this differential equation. So what is the solution? So by using operator D, the equation can be written as the given equation is. So what is this? So use operator D. So this can be written as d cube minus 6d square plus 11d minus 6 into y is equal to 0. Okay? Therefore, the auxiliary equation is. What is the auxiliary equation? So that is d cube minus 6d square plus 11d minus 6 is equal to 0. To find the roots of that equation, we write the auxiliary equation. So this equation can be written as d cube minus d square, okay, minus 5d square, okay, plus 5d plus 6d minus 6 is equal to 0. So minus d square minus 5d square is minus 6d square. 5d plus 6d, 11d. Okay, so we common out d square, so that is a d minus 1. Minus 5d common out, d minus 1. Minus 5d common out, so this is again a d minus 1 plus 6 common out here, d minus 1. Again common out d minus 1. So d minus 1 into bracket d square minus 5d plus 6 is equal to 0. Okay? So very simple example. So that is d minus 1. So what are the roots of that equation? So d square minus 5d plus 6. So that is a d minus 2. D minus 3 is equal to 0. So roots are d is equal to, so this equal to 0, we get 1, this equal to 0, we get 1, or this equal to 0, we get 3. 1, 2, 3. Okay? Then what is the solution? By using that formula. Okay? By using that formula, what is the solution? So what is the solution? So this is m1, say m1, m2, m3. And what is the solution? If 3 roots are there, then the solution is y is equal to c1 e raised to m1x plus c2 e raised to m2x. We know that solution. So c3 e raised to m3x. So that is, put here m1 is equal to 1. So c1 e raised to x. m1 is 1 plus c2. What is m2? Is 2 e raised to 2x plus c3 e raised to m3 is 3x. Okay? So this is the solution of the given differential equation. Okay, so this is very simple. Okay, so we take another example for you. So very simple example. Let us take example here for solving you. Solve it where the roots are different. Roots are distinct here. So solve example. Solve d raised to 4 y by dx raised to 4 minus 5 d cube y by dx cube plus 5 d2y by dx square plus 5 dy by dx minus 6y is equal to 0. You solve that example. So this is reduce this equation to putting d is equal to dy dx operator, find out the roots and write the solution of the equation here. Okay, so this is the example for you. You solve it. So if the auxiliary equation, next method, if the auxiliary equation with repeated roots, equation with repeated roots, then what happen here? If the roots are repeated, then what happen? So let us consider, let we take the auxiliary equation, general auxiliary differential equation. So dn, it's auxiliary equation. Okay, dn plus p1 d raised to n minus 1 plus p2 d raised to n minus 2 and so on, pn is equal to 0 here. So this is auxiliary equation. Okay, so this equation has n roots here. N roots, say it has n roots. N roots. So this equation has n roots. Say, so that is m1, then m1 again, m3, m and so on, mn. So this equation has n roots, 1 to n. But in these roots, the first two root is repeated twice. Repeated twice. So m1 is repeated 2 times here. If roots is repeated twice, then what is the solution of that equation? Okay. So then the solution is, we directly write here without solving, not necessary to solve here. Solution is y is equal to c1 plus c2x into e raised to m1x. Its solution is very simple by using first order degree differential equation. So then c3 e raised to m3x and so on, cn e raised to mnx. Okay. So if the roots is repeated, what happens? Roots is repeated 2 times, then this is the solution. If the roots m1 repeated 3 times here, m1 repeated 3 times, then what is the solution? Then the solution is what? c1 plus c2x into c3x square e raised to m1x plus c4 e raised to m4x and so on, cn e raised to mnx. Okay. If the root m1 repeated 3 times, then c1 plus c2x plus c3x square and so on. If repeated r times, then you can write in the same manner, we get solution here. Okay. So what is the example of this type we are solving here? Very simple example where the roots are repeated. On the same type, we take example. Okay. Solve. dqy by dx cube minus 5 d2y by dx square plus 8 dy by dx minus 4y is equal to 0. Solution. So solve this differential equation here. So the auxiliary equation is putting operator d. So that is the d cube minus 5d square plus 8d minus 4y is equal to 0. Okay. So this, by using operator d, we can write this equation in this form. So what is the auxiliary equation? Its auxiliary equation is d cube minus 5d square plus 8d minus 4 is equal to 0. So find the roots of this equation here. Very simple. Okay. So d cube minus 2d square, this can be written as minus 3d square plus 6d plus 2d minus 4 is equal to 0. 4 is equal to 0. So minus 2d square minus 3d square is minus 5d square. 6d plus 2d is 8d minus 4. Okay, common out. D square. So this is d minus 2. Common out minus 3d from those term here. D minus 2 plus 2. D minus 2 is equal to 0 here. Okay, is equal to 0. So d minus 2 into bracket. Again common out d minus 2. So d square minus 3d plus 2 is equal to 0. So what happened here? So d minus 2. So what are the roots of this equation? D square minus 3d plus 2. So that is d minus 2, d minus 1 is equal to 0. Roots of this equation is are these, and this is as it is. So d is equal to 2, 2, 1. Okay. There are three roots. Third degree equation, third order differential equation. Okay. There are three roots, and first root is repeated 2 times. So this is repeated 2 times. So what is the solution? Therefore the solution is. So what happened? So this is solution is y is equal to, using formula here, c1 plus c2x into e raised to 2x plus c3 e raised to m2x m3x e raised to x. Okay. So this is a very simple example. Okay. And come here, just what happened here? C1 plus C2x e raised to what? E raised to m1x plus C3 e raised to m3x. So this is m1. So this is m1 and this is m3. Put this value here. m1 is equal to 1. So we get e raised to x. So this is a very simple example of the same type. So we study next when the roots are complex or imaginary roots. Roots are complex or imaginary. So auxiliary equation with imaginary roots. Imaginary roots. Okay, so auxiliary equation. If the roots are imaginary, then what is the solution? So what is the auxiliary equation? If let we consider here the auxiliary equation d raised to n plus p1, d raised to n minus 1 plus p2, d raised to n minus 2 plus and so on, pny is equal to 0. So this is the auxiliary equation. Okay, pn, just no p, y is not there. So that is plus pn is equal to 0. It has imaginary roots. It has a complex roots. Alpha plus I beta and alpha minus I beta. Say then, if these are the two roots of this equation, so those two roots are imaginary, then what is the solution? But those two roots are different. Then by first method, so what is the solution? Y is equal to C1 e raised to alpha plus I beta. So this is M1. into x plus c2 e raised to alpha minus I beta. So m2 x. So this is a solution. Okay. So this can be written as c1 e raised to alpha x plus I beta x plus c2 e raised to alpha x minus I beta x. Okay. So we common out e raised to alpha x. Just a minute. What happened? So c1 e raised to alpha x into bracket e raised to I beta x plus just c1 is here, only common out e raised to alpha c1 plus c2 e raised to alpha x taking out e raised to I minus beta I beta x. Okay, beta x. Okay. So this equal to e raised to alpha x. So c1 into, so e raised to I beta x is a transcendental function. So what is a transcendental function in terms of circular function? So this is what? Cos beta x. Transcendental function in terms of circular function. Cos beta x plus I sin beta x. Okay? Plus c2 into bracket. So what is e raised to minus I beta x? So this can be written as, in terms of circular function, cos beta x minus I sin beta x. Okay. So this is equal to e raised to alpha x. Okay. E raised to alpha x. So this can be written as cos beta x common out. So that is c1 plus c2 e raised to just a minute, cos beta x plus okay I into c1 plus I into c2, so that is minus c2 I taking out c2 sin beta x. Therefore, so y is equal to e raised to alpha x. Here c1 and c2 are constant. So c1 plus c2 we say here a cos beta x plus, so this is I constant, c1 constant, c2. So this is a constant. So we say that constant is b sin beta x. So this is the solution of this equation when the roots are complex.